Hi, this is John Brown, and I'm here at Micron in their booth with Jason Massae. He is their expert on all things VSAN. Jason, good to speak with you.
Good to speak with you.
So, a lot of workload and performance-oriented exhibits here within the booth. And I wanted to talk to you about performance. Usually virtualization performance is associated with like noisy neighbors,
right?
Or scale concerns.
Mm-hmm.
And the question is really how are can you show me how you folks are addressing some of those issues with some of your vSAN-enabled solutions?
I sure can. We don't worry about those anymore. With an All-Flash VSAN, it's pretty much the noisy neighbor, the scalability, the complexity, all that stuff goes out the window. We did a 4-node VSAN here, and this was specifically tailored for VDI. And one of the things that kind of made this unique is that some of the requirements that you have to do for VSAN, VMware has some specific requirements. So to do, say, an 800 desktop solution, you have to have, they say, about 1 gig per VM. We did 3 gigs. The other thing they say is we need about 25 IOPS. Okay, well, let's think about 25 IOPS. Your laptop can do 100. So why would I give my corporate user 25?
Because I want to make them angry.
Right, exactly. I want my help desk phone to just ring off the hook, right? And then, of course, we just did the same with the two CPU. So when you look at that, you're saying, okay, so for a 4-node vSAN, I need about 25 cores per node. I need about 600 gigs of RAM and about 3 terabytes of storage. So when we did that, we kind of priced it out, and we came out to about $200 per desktop. Now, there's a lot of monolithic external type SAN, NAS. You can't even get close to that price. And that's for the storage alone. This includes the compute.
That's impressive.
If you go into looking at, so now that we step into the performance, when we ran some of these tests, we used a tool called Login VSI, which is kind of an industry standard for testing virtual desktop deployments. And when we deployed this, when we first did it on all 4 nodes, we had a 1,000-seat license. We couldn't hit max. We actually just ran out of licenses. We were not even close to RAM, and we were not even close to the latency on the desktop. So we played some games with it, forced it to run on 2 nodes, but still using the vSAN from the 4 nodes, and we got over 300 desktops per node.
Wow.
So going back to where vSAN says, we will support 200 desktops, if we can run 300 with just the same price, basically, you have plenty of headroom for those noisy neighbors.
Wow.
You have plenty of headroom for somebody doing even a heavy database on a VDI cluster. We could handle that no problem.
So that is impressive.
One of the other things that we wanted to talk about when I go back to that, an external SAN or NAS, even if it's, let's say, an all-flash array, they are fast. In fact, VDI is the reason all-flash arrays kind of came into play, is because VDI is so spiky. So here's one of the problems. If we go back and we pull the storage out and isolate it, we're looking at a cost that's over $200K versus about $160K for 4 nodes.
Okay.
Now here's the thing. That's 4, we'll say it's 4 external servers that are connected to that SAN. I'm probably going to get pretty good performance. But if I scale, every time I add another node, I'm dividing the performance of that array.
Okay.
So my scale, it doesn't scale. It actually reduces. So if I got 4, it's divide by 4. If I have 8, it's now divide by 8. Whereas on an all-flash vSAN, every time I add a node, I get all of the performance and all of the capacity and all of the compute. So the scale goes up, not down.
So it's a really much more efficient way
Extremely
of
efficient.
building out, complex environments.
Yes.
That is pretty impressive. Why should customers choose all-flash vSAN versus hybrid? Hybrid, we're certainly hearing a lot about that.
Yes.
As sort of that interim, well, you can save a few pennies here and do whatever, but really, what's the rationale?
So the rationale is with the difference between all-flash vSAN and hybrid. Hybrid has to use cache to write, correct? And it also has used cache to read. So there's a 70-30 mix there. So here's the problem. If you run past that cache, you run into what we call the hybrid cliff. And you immediately now go to the performance of your spinning media. And we all know how bad that is.
Yes.
Even with say a 15 or a 10K SAS, which is as expensive or more expensive than an SSD, you now have gone from 70,000 IOPS to maybe 900 if you go for the really expensive ones. So what are you saving? And this graph here, this was running some databases on an All-Flash VSAN and then also a hybrid VSAN. As we added more databases to the All-Flash VSAN, our performance went up.
Yeah, I see that, and linearly as well.
As we added all databases to the hybrid, it immediately started going down. And now you can get hybrid to do this performance, but it takes 3 times as many servers. So again, are you saving money? No, you are not saving money. So hybrid VSAN is a bad idea. Just really don't do it. Because unless you know exactly what your workload is, and you know for sure that you're never going to go past cache, you're going to fall into the hybrid cliff.
So that makes sense. And then even from the performance looks great. So this is pretty impressive technology that we've seen here. Thanks a lot for this. But before we go, if somebody wants to get more information about Micron and what they're doing with VSAN and All-Flash, where should they go?
So you can go to micron.com/virtualizations.
Okay.
Virtualization.
All right, and it's important to actually go to the virtualization.
So micron.com/virtualization.
Okay, well, thanks a lot. I really appreciate it, Jason. It's been a pleasure.